The biggest issue facing data centres today is power, both the cost of power and the availability of power. Power is one of the few commodities that actually costs more the more you use. The cost per kilowatt hour increases the more you use. The advent of high-density computing, especially blade servers, has led to unprecedented demands in power. Now, you may be surprised to find that less than half the power consumed in a data centre is actually consumed by the IT equipment. The other half is consumed by the equipment used to power and cool those IT servers. So picture this: a single blade server can generate as much heat as 2 to 3 kitchen ovens with their doors open on full power. Now imagine there were 6 of these in a rack and there were hundreds of racks in a data centre. You can really start to understand why cooling this equipment has such a big impact on cost. If we were to look at the dynamics of a data centre today, there are 2 very big things happening. The first thing is the equipment in there is getting hotter. It's more densely packed, it's taking more power in and generating more heat for the volume that it's taking up. The second is traditional underfloor cooling has actually reached its limits, its physical limits. Traditional underfloor cooling from computer room air conditioning can cool up to about 5 kilowatts a rack. That's its limit. Given that blade servers, an individual blade service can be over 5 kilowatts and you may have 2, 3 or 4 of these in a rack, you can clearly understand that just pushing more and more cold air through computer room air conditioning is not going to solve the problem. So what data center operators are looking for is a framework where they can observe and analyze energy efficiency across 3 major areas: the IT equipment, server utilization, etc. The second area is operational best practice, hot aisle, cold aisle, virtualization, etc. The third area is infrastructure. Infrastructure is in how to most efficiently power and most efficiently cool their data center.